Hi, this is going to be an example of how to run efatigue's stress life calculator and get meaningful answers. First thing I'm going to do is from the main efatigue page, I'm going to click on constant amplitude calculators, and specifically I'm going to pick the one called stress life. You notice that this brings me instantly over to constant amplitude stress life page. And the way that you work with this thing is to scroll up and down until you see the inputs that you want to work with. So I'm going to show you that I'm a reasonably experienced user, and I'm just going to go ahead and very quickly set enough parameters so that we can do a meaningful prediction. So first thing I'm going to do is assume that my input is in terms of strain. So I'm going to choose units for strain to be millimeters per millimeters, and I'm going to choose my maximum strain in the cycle to be 0.001 or 1,000 microstrain. Second value, the minimum value, I'm going to set to minus 0.001. So I'm going to do a little bit of completely reverse loading. Second thing I'll do here is immediately pick the material properties. Now you have the options, if you know the numbers that go along with the stress life curve, in particular the intercept of the straight line portion of the SN curve and the slope of the curve, then you can enter them directly in these fields. However, efatigue has a better deal. You go to the material property finder and choose the material that you're interested in. In my case, I'm going to consider 1045 normalized steel. So it finds the properties for that, and instead of me having to transfer and type this information back in my calculator, I'm simply going to use it in my present constant amplitude stress life calculation. So click on that. Next thing we get to is, now that we have material properties, is consider some of the modifying factors. So the first one I want to consider is surface factor. This basically changes the slope of the SN curve in the same way that a notch factor would. And so I'm going to choose the surface to be a machine surface in this case. Second one is this loading factor. I'm going to assume my loading is axial instead of bending. And from there I'm going to jump to the stress concentration factor. I'm going to assume I have a value of 2.5. And I'm not going to make the change over to the effective notch factor. I'm just going to use the notch factor I have entered. And my last step in this very quick analysis that I'm going to do is to go down at the bottom and use this opportunity to calculate the life, or the safety factor, if we have infinite life. So I click on the Calculate Life Curve button, and I find out that this under this particular strain cycle, this piece of material with this notch and machine surface will last about 4,000 cycles. I can get a better view of this by clicking on the printer ready view of these results. This is something that I would feel good about printing out and handing to somebody else. Okay, we'll come back later and do a more detailed type of analysis.